Welcome, everyone. Welcome back. Appreciate everybody hanging in there this week uh, as we learn to navigate through this remote learning process. I appreciate everybody hanging in there. Some students have called with some advice or tips or telling me that something's working or something's not working. Um, but we moved along. We did a few things. Um, Today, we're going to finish up the week talking about angles of elevation and depression and a few of these application problems that you had last night for homework. We're going to take a look and see what a few of them look like. Again, application problem. Application problem regarding sine, cos, and tan. You're always thinking triangles, so as they tell you the story, I always recommend sketching something to get some sense of what the triangle is going to look like. So bear with me on our pictures. A person is standing 40 feet from a flagpole. Person standing 40 feet from a flagpole. So here we go. Easy on the critique of the drawing. Flagpole, 40 feet, person, 40 feet from the flagpole. Not bad, right? Okay, and you can see the top of the flagpole at an angle of 35 degrees. Now, here's where it gets a little tricky. The person's eye level is 4 feet from the ground. So we're going to assume, and this is the only way we can make the problem work, is that they're talking about from the eye level. They could have done a little better job, but from that eye level, which is 4 feet above the ground, so here's the ground, right? And then, so therefore this distance here is 4 feet, right? 4 feet right there. But anyway, back to our problem. This angle is 35 degrees, correct? The angle of elevation, okay, is 35 degrees, 40 feet from the flagpole. How high is the flagpole? Well, here's our triangle, right? Here's our triangle. This piece here of the triangle, this side, is parallel to the ground, but it's 4 feet up. But you can see where we're going with the strategy. If we can get that side length there from the triangle, which is just this distance, right? That distance there. And I think we can do that now. We've got a 40 foot, we've got a side length that's x, and we got an angle 35 degrees. You can see that once we get x, what are we going to do? Once we find out that distance, what will we have to do to get the flagpole? We'll have to get that extra 4 feet in there. And that doesn't seem like too much of a problem. We'll just add 4 feet to whatever we get over here. So that's where you had to do a little improvising, and I think to get the answer that the book wants you to get. So what are we dealing with here? Sine, cos, or tan? Well, we're going to deal with a 35-degree angle, and this is the opposite side, and this is the adjacent side. So by now we're starting to get used to tan. So the tan of a 35-degree angle equals opposite over adjacent. So that's our equation that's going to be our equation for problem number 13. Okay, so let's get x. We put 40 times tan 35, 40 times tan 35, so that x turns out to be 28, right? That length there is 28. What do you think? I think we can do that. Now, to answer their question, they want to know the height of the flagpole. Well, they did the eye level thing. I'm going to put the eyes right there. The eye level. So I say the height of the flagpole is 32 feet. Where did I get 32 feet from? 28 for the side, 4 more feet above the ground. So I say the height of the flagpole is 32 feet. That's problem 1. Don't forget, you can email me any questions you have, especially during the class, but I'm always checking the email. If you have a question to say, I didn't understand where the 4 came from, or I didn't understand how you got from 28 to 32, or whatever why didn't you use cos? A few students have been asking questions via email or streaming. That's fine. I'm looking forward to it. I don't want you sitting there not knowing and being stuck and wondering about it. Let's go to problem 14. We're, I won't keep this video going the entire time. I think we're going to pick and choose a few, and we'll see. 14, an eagle perched 40, oh boy, here comes a picture. An eagle perched 40 feet up in a tree. Okay, here we go. Tree, eagle, oh boy, there's the eagle. I got to put a, okay, eagle up in a tree. I can hear you laughing from here. An eagle perched 40 foot up in a tree looks down at a 35-degree angle. They do a bad job, I think, Pearson. So this distance here is 40 feet, right? The eagle looks down at a 35-degree angle. I think they should have said at a 35-degree angle of depression. They didn't really say that. They should have said it. The eagle looks down at a 35-degree angle of depression. It just didn't, those extra words would have made it clear in my mind that that's where the angle should be. Okay, so here's our right triangle. Now this eagle's looking down at 35-degree angle of depression and spots a vole. Now I had to look that up, and a vole is like a mouse. So there's the mouse. A vole is like a mouse, and spots the vole. How far is the vole from the eagle to the nearest tenth of a foot? How far is the vole from the eagle? Now, some folks might say, well, this distance, but that's not where the eagle is. I say the book wants us to find this distance here, that distance there. That's the eagle to the vole. Now, hold on a second. We got to use our triangle. We have a side length here that's 40. We have a hypotenuse there that's x. Now, if we want to use one of these two angles for this particular triangle, keep in mind from yesterday that if that angle's 35, the alternate interior angle down here would also be 35 degrees. So that's the twist when you're dealing with angles of depression, right? That's the twist on that you have to be alerted to, okay? So from here on in, I think we got this down. Okay, again, don't forget this, when you have a vertical line and you have a horizontal line, this is 90 degrees. So if that's 35, right, if that's 35, 30 is 90 minus 35. This angle here is going to be 55 degrees. So you have a choice, but let's go ahead and use that 35-degree angle. Now, if we're going to use this opposite hypotenuse, what are we going for then? Our equation is sine 35 degrees equals opposite over hypotenuse, right? Now comes our last step. We've been practicing these. We're going to take the 40, and because the 40 is on top, we're going to take in our calculator 40, and then we're going to hit the division button, and then we're going to hit sine 35. And when you do that, that number comes out to 69.7. I think the assignment said to the nearest foot. Okay, so nearest tenth of a foot, 69.7 feet. Okay, again, key, angle of depression versus angle of elevation. Right, you always want to be careful on that. Angle of depression versus angle of elevation. I think we're okay on that one. I hope we're okay on that one. I think we got time for one more. And then I'm going to give you a few more problems to practice, and we'll review those Monday and kind of wrap things up. How does that sound? I don't want to keep you here all night. So let's see where we are. I think I assigned number 20, and it can be a little confusing, but let's do it. Number 20 says an airplane's flying at an altitude of 10,000 feet. This is number 20. an airplane is flying at an altitude of 10,000 feet. So far, so good. There's our airplane. The airport at which it's scheduled to land is 50 miles away. 50 miles away. Now, they just pulled a fast one on us. Did you notice that? 50 miles where the altitude's 10,000 feet. So we have to convert this to the same unit of measure. So they threw this one in on us, but that's okay. There's 5,280 feet in a mile. So we're going to take that number and multiply it by 50 miles. By 50 miles, okay? So when you multiply that by 50, I come up with 264,000. 264,000. So the airport at which it's scheduled to land is 50 miles away. So I say this distance here is, what was that number I converted to? 264,000 feet. That's 50 miles. Turns into 264,000 feet. So now I have them both in feet. So that was a fast one. Okay, they do that from time to time. Now find the average angle at which the plane must descend. I would, on a quiz or a test, wording that myself, I would say, what is the angle of depression in which the plane would land at the airport? What is the angle of depression that the plane must take in order to land at the airport tower? Okay? So we're looking for this angle measure. Now keep in mind, it's an angle of depression problem, right? An angle of depression problems, okay, can be a little bit confusing because some folks are thinking of this angle. An angle of depression is formed by a horizontal and another line going down, right? This would be a vertical and a line swinging to the left, going up, okay? So here's your angle of depression. What is the angle of depression that the plane must take? X. Remember what we did before. Alternate interior angles are going to be congruent, so those two angles are going to be congruent. Now we want to find the measure of that angle. How do we find the measure of an angle when we know two sides? Ready? Opposite hypotenuse. Opposite hypotenuse. Opposite over hypotenuse is sine. So we take opposite over hypotenuse, and we're going to put that in our calculator. And how are we going to do that? Remember, second button, or if you have another type of calculator, Casio, possibly shift. But second sine 10,000 divided by 264,000, enter. Okay? And when you hit 10,000 divided by 264,000, after you hit second sine, I come up with it rounding to about 2 degrees. 2 degrees, a 2-degree descent. Okay? So x is 2. When you hit second sine, 10,000 divided by 264, or 10 divided by 264. Okay? So that's a variety of a couple of different problems about angles of elevation and depression. Don't panic if your drawing is not perfect. It doesn't have to be. I'm going to give you a few more problems to practice on today and kind of wrap up the week. It was an experimental week for all of us, teaching 40 years. This is the first week where I've taught like this. So it was a big change for me, probably bigger than for most of you guys. And I appreciate all your cooperation and the effort, really on just about everybody's part, to try to cooperate and to try to do the assignments. Do not panic if the assignments are not perfect. Still submit the homework assignment the next day. You can review the answer key first, but submit the assignment at least so I can see that you made an attempt to do it, that you looked even at the answer key, and I can give you some credit. We're going to try to assign like 5 points for a completed homework assignment. And I'm doing my best to review them, but I'm still getting myself organized this week with regard to that. And we're going to try to come up next week with some sort of small little quiz. It'll have to be, Scout's honor as far as doing that, but at least sort of an assessment that'll kind of, we'll be able to stop and say, okay, here's these 2 sections, and we're going to have a little quiz on it and see how we do. Okay? So thanks a lot. We'll talk next week. A few more Hughes tubes coming up, and there's an assignment attached today to the classwork. Give those a shot, and we'll talk about that on Monday a little bit more. No homework. Take a breather, and again, thank you very much.